This is the only day that some of these formulas are ones you have to have memorized. Everything after a day I'll give you every time. But the reciprocal identities, you should know these. We've already talked about how cotangent and tangent are reciprocals. We wrote it down one way, but it's also true that tangent is 1 over cotangent. And cosine is 1 over secant. And cosine is 1 over cosecant. So those are reciprocals. You should know which ones are reciprocals. We also can talk about quotients. We've mentioned these before. So again, I'm not giving you those on the formula sheet. Tangent is sine over cosine. Cotangent then is cosine over sine. Pythagorean identities, these are on the formula sheet, so those are given. You don't have to memorize them. However, we can use variations of these as well. Sine squared plus cosine squared equals 1. We've used that one before, but it may not always look like that. You know, you could subtract over the cosine squared, which means sine is 1 minus cosine squared. Or I could subtract over my subtract over my sine. So cosine squared is 1 minus sine squared. So we'll use variations of these formulas. They don't always have to look the same. The last set that you wrote down, these negative identities, we talked about these with graphing. I'm not putting those on the formula sheet either. Remember with graphing we said cosine and secant were the only even functions. So if they have a negative, you can just drop it. Everything else, if it has a negative, you pull the negative out in front. Okay? So, what I really want to stress today, we are just starting these problems, but there is no way to really ease into this stuff. It's just kind of a jump in and go kind of thing. So it's a little daunting at first, and it doesn't have to make perfect sense today. Okay, it just takes practice. So today's homework assignment, I'm going to tell you when I give it to you, it's a completion grade. I want you to try everything and see how far we get. It's not something that you are going to master in one day. We are working on this the whole chapter. But we are going to be today just practicing manipulating these formulas. So I'm going to give you a trig expression, and we are going to use these formulas to write something equivalent to it. So here is our first example. I want to simplify cosecant x minus cosine x cotangent x. I would make sure I wrote down all these examples. Several of the ones on your handout are very, very similar. I also want to stress that on these problems, your answer is not just the final answer. Your answer is the work that goes with it, because we are going to start proving things. And in proving, you have to show all the work and how you get to your answer. So it's not a skip steps and just write down the final answer type thing. So a good strategy, if you don't automatically recognize any formulas when you look at this, you know, I don't see like a sine squared plus a cosine squared that I know is equal to 1, change things to sine and cosine. If you don't know what else to do, always go back to sines and cosines. Cosecant, how can we rewrite cosecant? 1 over sine x. You do have to write the x with it. It can be x, it can be theta, it can be a y. It's just representing an angle. Minus cosine x, there's really nothing I'm going to do with it, times cotangent x. If we're changing sines and cosines, how would we write cotangent? 1 over tangent, but if I want to go to sine and cosine, what else could I do? Look at your quotient identities. Cotangent is cosine over sine. Okay, now we're really just using algebra along to simplify this. This is like a cosine over 1. So if you're multiplying fractions, you can just go straight across. Cosine x times cosine x would be cosine squared x. and we typically write the square by the cosine. 1 times sine x is sine x. Now, in order to add or subtract fractions, what do you always have to have? Common denominator. We have, so we can put them together into one big fraction. So that's 1 minus cosine squared x over sine x. What's 1 minus cosine squared? One minus cosine squared would be equal to sine squared x over sine x. And we are almost there. What would be sine squared divided by sine? Just a sine. So our final answer is sine x. Did I lose anybody along the way there?
So whenever there's an x, it can be theta.
Yep. Theta represents any angle, so basically any variable of your choice. Any other questions? Let's keep manipulating this. So 1 plus cotangent squared x over cotangent squared x. A lot of times there is more than one way to do these problems. That's another reason why you have to have your work to show what you did. I can think of 3 different options for how to start this problem right now. So what stands out to you guys? Anything that you think you could do? Okay. You can't just like multiply to get rid of the cotangent because we don't have an equation where there's an equal sign, but if it was equal to something, then yes, you could do that. You could
change it to cosine.
Okay, that's one option. Look at your formula sheet. What is 1 plus cotangent squared? Cosecant squared. Okay, that's not the only way to get here. I'll show you another one in a second, but this is one option. Now this doesn't strike me as anything special, so let's go to sines and cosines. Cosecant is 1 over sine. Cotangent is cosine over sine. Notice that works, those reciprocal and quotient identities work whether it's just a regular cosecant or cosecant squared or cosecant cubed. I just had to make sure I put my squares on everything. Okay, think about algebra. How do you divide fractions? Flip and multiply. So the top one stays the same, times, and then I flip the second one. So it becomes sine squared x over cosine squared x. What happens now? Sines cancel. So then you have 1 over cosine squared x, and 1 over cosine is? Secant squared x. Again, this is not the place to skip steps. Your steps are your answer. And that also wasn't the only way to do it, depending on what strikes you as an option. You could have, since we only had one term on the bottom, you could have split it up and put each thing over the denominator. What's 1 over cotangent? reciprocal of cotangent is tangent squared x. Those would cancel and just leave me with a 1. What's tangent squared plus 1? Secant squared x. So, same answer we got before, but a different path to get there. Is that one okay? We're going to do some more. Any obvious formulas jump out to you? So we probably need to FOIL this. Let's change the sines and cosines before we do it. We can do it before, we can do it after. It's not going to make a difference. What is secant? 1 over cosine. Cosecant is this times cosine theta minus sine theta. If it helps you, you could put each of those over 1. That makes it a little more clear to you when you multiply. So if I FOIL, when you multiply fractions, you multiply the tops together and the bottoms together. So that gives me a cosine theta over cosine theta minus, this one gives me a sine theta over cosine theta. And this one gives me a cosine over sine minus sine theta over sine theta. You guys all understand how I got to that point? What is cosine theta divided by cosine theta? 1. Minus, what is sine theta over cosine theta? Tangent. Plus, what is cosine theta over sine theta? Minus, sine theta divided by sine theta. What happens? The 1's cancel. Positive 1 and negative 1 cancel. And you're left with a negative tangent plus cotangent. Or if you prefer, you could write that as cotangent minus tangent. I don't care.
Grabbing the base, gotta get to third. I've been working hard for cocaine. I'll take conservative. If he says I have no workout for him, I'm gonna sign it to him.
I'd like to maybe do 2 more together and then just give you guys maybe 1 more. We'll see how we're doing on time after this. Let's go ahead and do this one and then I'll probably might stop. We'll see. Okay. First of all, I want to clarify something. When you see a cosine squared, you don't necessarily have to write this step down, but I just want to make sure you understand what it means. You're doing cosine of negative theta and then squaring that answer. Tangent squared of negative theta means you're going to do tangent of negative theta and then square it. Now, using properties of negative angles, if you have cosine of a negative, what happens to that negative? It just drops. What about if you have tangent of a negative? Goes to the front. Okay, so the top is just 1 minus cosine squared theta. On the bottom, if you square a negative,
If your tangent was negative, what would happen?
like if it were negative up front already, it would become positive. When you square a negative, what happens? It becomes positive. So this is just still 1 plus tangent squared theta. Okay. We have options from here. Do you recognize anything? What is 1 minus cosine squared? Sine squared theta. What is 1 plus tangent squared? Secant squared theta. Okay. I think we can do a little bit more. What can I change secant to?
Oops.
1 over cosine squared. And to divide fractions, you flip and multiply. So it'd be sine squared times cosine squared over 1. When you multiply those, you just get sine squared theta, cosine squared theta over 1. You can drop your denominator. We know anything divided by 1 is itself. So my final answer is sine squared theta times cosine squared theta. What do you guys think? Do we need another? How about we try one more? It won't hurt us to see one more example. I know this one was a little bit harder, a few more steps. Did I lose anyone along the way? Last example for the day. This first one. How do you square a parenthesis like that? FOIL. It means we have 2 of them. We have to FOIL. So if I do that, sine times sine is sine squared. Sine x cosine x plus sine x cosine x would be 2 sine x cosine x. Cosine times cosine is cosine squared x. Minus. We have to do the same thing here. So sine times sine, sine squared x, minus sine x cosine x, and minus sine x cosine x would be minus 2 sine x cosine x. Negative cosine, negative cosine is a positive cosine squared. What would I do now? We have a negative, so if I run that through, and then combine like terms. Positive sine squared and negative sine squared would cancel. Positive cosine squared and negative cosine squared cancel. So I have 2 sine x cosine x plus 2 sine x cosine x, which is 4 sine x cosine x. What I'm going to do now, we have 15 minutes, I'm going to give you guys a handout and I want you to try them. So your homework, you have to try every one of these, and that's more than just writing one line. You have to try something. If nothing else, change everything to sines and cosines and see how far you can get. But I really think you can get a lot of these to work.